Hey y'all, how's it going? I'm Emerson Murphy Hill. I'm happy to be accepting this award for the VISSOFT Most Influential Paper Award Top for 10 years. Can't believe it's been that long. I'm presenting about this paper that we had at VISSOFT 2010 about an interactive ambient visualization for code smells. It was work that I did in my dissertation with Andrew Black, and yeah, very honored to be getting the award. It was a nice surprise. It's a paper that obviously we worked hard on, and some work that we were really happy with, and great to see recognition for it. So thanks very much for that. So I want to talk to you today about a little bit about what the visualization was and some reflections about like what sort of sense or what we think the most important lessons are since it was created. And again, I'm Emerson. I'm a research scientist at Google, and Andrew P. Black is a emeritus professor at Portland State University. All right. So in my dissertation, there was the way that I framed the process of refactoring. So refactoring, right, restructuring code without changing the way it behaves. We sort of framed it around this idea of refactoring as this workflow, and we broke it down into these different steps. So the first step you do is the thing at the upper left there. You identify the code that you want to refactor. Then you select the code you want to refactor in your editor. You initiate the refactoring tool. This is, by the way, all assuming that you're going to use a refactoring tool. Typically on a menu or with a hotkey, you might do some configuration of the refactoring. So choosing the name of an extracted method, for example, executing refactoring, and then interpreting the results. Did you get what you wanted? Great. A little bit of cleanup might be necessary. If not, you got something you didn't expect, you might undo it, or you might get an error that's actually surprisingly common from a refactoring tool, in which case you got to sort of go back and do some other work. Sort of think of it as a sort of cyclical recursive process. And this particular paper was about one step, and in fact, my dissertation, each step here made a nice little chapter and a paper on its own. And so the identify step was how do people identify code for refactoring was the insight here that we thought was going to be fruitful to look at. And so one of the, again, one of the insights that I think in retrospect worked really well is that like breaking down a common programming activity into steps is a really nice way to sort of structure a dissertation and generally break down a problem. So let's take a minute to sort of look back about how do people identify opportunities for refactoring. Well, here's a nice cute class called Monkey that's got a peel method and a bunch of code within it. Um, the canonical way sort of to identify like whether this method needs to be refactored and how and in what part is Fowler calls code smells. And he catalogs 22 of them in his book. And they're just patterns for suggesting when a refactoring might be needed. Some judgment is required. And so of the 22 smells, there's a bunch of them. This first one is what he calls feature envy. So we've got a peel method in the monkey class, but kind of what you notice about it if you look at it, in a little bit of depth, is that like we're calling a bunch of methods on banana, but like really nothing on the monkey class itself. So like, shouldn't peel be part of banana? Isn't that kind of what this is saying? And specifically, this class monkey is kind of envying the banana class. So that's a feature envious smell. Doesn't mean you should definitely refactor, but you should consider it. So other ones are Fowler identified casts as a smell, and he identified having a class that's really big as a smell. And also he said, magic numbers that appear in your code and don't have any particular explanation for why they're there. They're magical. Those numbers you'd ought to consider, extracting a constant for example, to give a description, to give a descriptive name to. So what we came up with to help developers find smells was this tool that we called Stench Blossom. So the name, I will have to give credit to my wife for this, Claudia, while she was helping me through grad school, as many supportive spouses do. We talked about this visualization. The visualization looks kind of like a flower, and it's about code smells. And so she thought stench blossom would be a good name. And actually, the name comes from The Simpsons, the TV show, and it refers to, I don't remember whether it was Bart or Homer said, a rose by any other name would smell as sweet, and Bart or Homer said, not if you called it a stench blossom. Um, and so, cute name for sure, and it seemed pretty fitting here. So thank you, spouse. Um, so anyway, the visualization is ambient, as the title suggests. It's this visualization that kind of lives in the background of the editor. And as you move in your code, the visualization sort of stays right at the center of the editor there. But the visualization itself changes based on what's in the code. So each little petal on the flower on the left represents a different smell. And so when you mouse over, it tells you what smell it is. And if you've used it for a while, you kind of remember roughly where each smell corresponds. So feature envy is the one that's moused over right there. It's at the right of the editor, so it's intended not to really be in your way. And it's kind of intended to be ambient and kind of like there at all times. And so it's also intended to sort of catch your attention at the right time. So here it's saying, well, feature envy is kind of this bigger smell. Maybe you should take a look and see what's going on here. So if you mouse over it and you click on that little plus next to feature envy, it'll show you something. Now, one little lesson here before we go on is, it turns out like if you try to do something kind of interesting like this in Clips, it doesn't work anymore. Turns out that I didn't realize it when I sort of coded this up in the first place, but it turns out that we're exploiting a bug here in Eclipse. The bug got fixed a year or a couple of years later. So, exploiting bugs for fun and profit, not just for security folks. Also nice if you're trying to hack editors to get like cool little visualization. Okay, so if you click on that feature envy thing, what you get is you get a more detailed visualization. So it's sort of a two-phase thing. In the more detailed, again, this is the one for feature envy. What it shows you is it's got this little panel that pops up at the right, and it shows you different classes. So different classes are broken down by different colors. So there's sort of a pink one that's DHT transport full stat, and there's a blue one, DHT transport UDP, and some other ones that are labeled as read-only, data output stream, and string. And it'll color the methods for each class, right, in a different color. And so you get a sense of like what classes are being called here. So you can see there's basically two, roughly looking at the code. Data output stream is being called a lot, and DHT transport full stats is being called a lot. And right there, you're seeing it sort of mousing. I'm mousing over the method itself, and it's telling me, where that method is being called. So the idea here, right, is that it's suggesting that probably DHT transport full stats might be a good place to move this method rather than being in the utils method, because this method's only calling its class once. It's only calling serialized byte array within this class, but it's calling a bunch of methods on DHT transport full stats. So it suggests that's actually a good place for it. And so on the hand, you could also imagine output stream is a good place to put this code as well. But the visualization is providing a little bit of a hint that maybe that's not the best idea, because it turns out that's a read-only class, so it would be probably more challenging to put it there or in some subclass. Okay. So that's it. That's the visualization. Each different smell has its own sort of detailed visualization that goes along with it. I'm showing you the feature envy one because I think it's kind of the coolest. Yeah. So that's the visualization. But one thing looking back here is you notice I'm not giving you a live demo of the tool, of the visualization. That's unfortunate. Well, it has to do with, in part, with that bug, which is to say, like this extension. I think we've still got the source code available on GitHub, but you can't actually like run it on a current version of Eclipse. So we didn't do enough work in retrospect to like make to archive this visualization. What you're looking at here with screenshots in the paper, great. Like obviously you have those. You want to make those available uh, to your um, to your readers. But also it would have been nice to have a little visualization or a little video that went along with it. Um, and I did make videos for it, but I translated. I didn't put them on YouTube. I put them on my own webpage and sort of put them in this little Flash player, which played very nicely at the time. But like Flash does not exist anymore, so it did not archive very well. So any other mainstream video archiving service like YouTube, not to promote our own products, but YouTube would have better place to put that video. And then finally, like the tool itself, how do you get that working? How do you get that so you can use it again at a moment's notice at a talk 10 years later? I think the right answer there, right, is probably to put it in a virtual machine with exactly the right version of Eclipse running on Linux. And so you can just spin up the virtual machine and the tool runs immediately. Some skepticism that maybe virtual machines won't work so perfectly like that in the future, but it's a lot better than what I had here. So make a nice video, put it on some long-term archiving place in a pretty standard format, and then also out of your tool make a um, uh, put your tool into a virtual machine with the entire stack of hopefully open source tools that you're using to make it go so that people can spin it up. And people have asked over the years, like, oh, can I get a copy of your tool? And it's like, of course, here's where you can find it. Oh, sorry, you're gonna have trouble getting it working. I wish I didn't have to give that caveat. I wish I could just say, here's the tool, you can get it going in 2 minutes or less. That would be pretty cool. So some regrets, some lessons learned there. So the tool itself, Stench Blossom, um, one of the things that I think really made one of the things that I liked about the paper a lot, and we used a bunch afterwards, is trying to articulate what made the visualization good, right? Um, and not just like obviously, we're all trying to make cool tools. We're making them the best we can make them. We're trying to make them as useful as possible. But like, what is it? Like, why is this visualization is do we think it's useful? Is it's not because I think I made it. I think it's because there's some very specific things that I can put my finger on, and sitting down and articulating those turned out to be really useful. So here's a list of the different guidelines. We called them guidelines. Might have called them, design guidelines or something like that. But these are things that we thought would help, future designers of tools, maybe in a similar context, make their tools more useful. So we just pick a couple of these that we think are important. So one of them, context sensitivity. So display smells that are relevant to the programmer's task. Sounds great, right? Sounds obvious in retrospect. Well, when you look at tools, a lot of tools that were built for code smells before ours, a lot of them would have just sort of very like high level views of code, which can be useful. But our insight here is that like developers are not often going to want to break out of their workflows. Developers are very busy fixing bugs and adding features, and having them like really break out of that workflow turns out to be a tough sell. And so having a tool that works with them while they're doing their work and maybe grabs their attention at the right time, we thought that was one of the really valuable things here. To pick sort of another one here, estimability. I think that's another good one. So help estimate the extent of the smells in code. So it turns out with these smells, like they're often not easy fixes, and how to do the refactoring isn't 100% clear. But we try to design the visualization in such a way that it gives you a sense of like how much work it's going to take to fix this problem. So for instance, with that, the feature envy one, we were looking at the previous slide, right? It says, okay, it tells you kind of what class that you might put it in. But it also says like, well, right in the middle of the method, there's a call to this class. So you're going to have to pass it in, or you're going to have to deal with that somehow. Maybe you put this into two separate methods, but it says it's not completely straightforward. You can't just move this method from class to class. And then maybe I'll pick one more to mention here, and that's bias. Not sure if I would use that same word again, but essentially emphasize smells that are hidden over those that are obvious. So this was in the site that we had, I think, pretty early on with code smells. Some of them are just like really obvious. So large class, for example, like any programmer looking at a class is going to know whether it's big or not. Like it's a very basic thing to do. And in some sense, like all of the smells, a competent programmer will figure out. But things like feature envy, when I'm looking through code, I'm not thinking about that often. I'm not thinking about, whether this class belongs in this class or another, and like what are the different classes that I'm working with here and how are they being called. I'm trying to work on a specific thing. So things like feature envy are less obvious. And so the tool tries to emphasize those by putting them sort of at the top of the flower. The obvious ones are at the top, the less obvious ones are at the bottom, and we try to use sort of an orange to indicate a little bit more urgency to grab people's attention, to sort of bias their attention more than the ones at the bottom that are more obvious. So those are three different guidelines, and actually they came in useful for other parts of the dissertation as well. Okay, and then let me just talk about the evaluation a little bit. So we did a little study, a little experiment with 12 programmers. We had them use Stench Blossom to find smells in some code that we gave them and make some decisions about whether or not to refactor. What we measured was, did they find more smells with the tool than without? And we asked them some questions at the end, sort of some qualitative data. Did they find the tool useful beyond sort of the code that we gave them? Would they want to use it on their own code? And then we also asked them about the guidelines themselves. This was, in retrospect, I think this was a good idea. I'm quite happy that we did this. Looking through the guidelines and say, like, do you think these are important or not? And do you think the tool actually exhibits these guidelines or not? So, it's not an objective assessment, so to speak, but it provides some more data about not just our intuition that the guidelines are, whether the guidelines are good or not. Okay, and so some things that sort of lessons we drew here. One is that like the evaluations are useful, but also that like they're never perfect. I think you can look at this and you can say, well, a lot of it's subjective. Um, their performance with the tool versus without the tool, maybe it should have been compared to some other tool if you think your tool is so great. So like not perfect in that sense, but actually like the act of having to sit down and design an evaluation and say, what is it that we think we can demonstrate with this tool? And what can't we? What can we measure? What do we need objective measures for, like, timing or number of smells found, versus what do we need subjective evaluations for? That's actually a really useful discussion to have, and like it's really where the rubber meets the road. It's not just I made this cool visualization. It's here that here's the way that I think it's useful. So the results are basically that did it find more smells? Yep, it found about twice as many. Do people think it was useful? Yep, everybody did. Did they want to use it in their code? Yeah, everybody but one. Are the guidelines important? Generally, yes. There was a little bit of disagreement around expressiveness and availability. And a little bit of reflection about the results here. In retrospect, these results seem kind of like shamelessly self-congratulatory. Like they're, I don't know, twice as many. it feels like this is a slide that I use in my dissertation, and I would have, if I were a committee member, I would have rolled my eyes at this. And another lesson here is I think self-disclosure is useful. I've started doing this since, and I didn't do it in this paper or anywhere in my dissertation, is this idea of like, what's my position with the work and what are the interests that I have? Obviously, like I made the tool, so I think it's great, and that may have rubbed off on participants. And so talking about like what the limitations are with respect to what sort of my identity brings to the work, I think is important. Okay, and then final lessons. I think visualizations should always be in service of an actual experienced engineering task, something that people always do. Visualizations, I think, aren't for themselves of themselves. They're supposed to help people do something. And also, I just want to say, like, quantitative evaluations are great, but not everything can be quantitatively evaluated. And I think there's lots of great innovations out there for which evaluations are actually really hard to do, and I think those are valuable nonetheless. Thanks very much.